Hi everyone, thank you so much for having me and being here for my talk, Go Pro with POROs. One of my big motivations for this talk was I personally have a penchant for words. I love words, I love learning new words, I love finding the right word, and that's really helpful in coding, and I probably really resonate with Ruby because Ruby is so expressive and word-friendly. And so I wanted to kind of put together a talk where I could start to use, build, and promote vocabulary around different design patterns in Ruby. A lot of these terms are going to be familiar to you, I think, but hopefully inspire you to kind of push the boundaries around them. I would love to have more conversations about them later today, because I know that there's a lot of wonderful ways to write Ruby code. So these are only a few examples, but I hope you kind of take something away from that as we go through them. So a little bit more about me. My name is Ifat Ribon, you nailed it. I'm a principal architect at an agency called Launchpad Lab. We are based out of Chicago, but we have developers from all over North and South America. And working at an agency has been a really wonderful opportunity to see a lot of different code bases, work with a lot of different developers, see their styles, learn from them, and also get the chance to explore and work through the different patterns that I've enjoyed or learned from others. So with that, I'm going to walk through a few themes that I want you to keep in mind as I go through this talk. The first is when we talk about code design, we're really talking about encapsulation. How are you organizing your code? What are the boundaries you're drawing around the business logic in your code? And there's so many ways to do it. You can go to one extreme where you sort of keep everything in one file, to the other extreme where you split everything apart in very small pieces. All of those are perfectly valid forms of encapsulation, and these patterns are different ways to do that. The next theme I want you to keep in mind is the idea of clarity. Again, I really can't say this enough. There are so many different ways to write Ruby, and they're all wonderful. At the end of the day, choose the patterns or the ways of writing that are going to be clear to you and other developers, and as the old adage goes, your future self is another developer, right? Something that's going to resonate with you when you come back to a code base months or years later, a bug that you never expected comes up, and you want to be able to quickly find it in your code or reason about that code as you look to extend it with new features. And lastly, the third theme or goal here is that of simplicity. So this goes along with clarity, obviously, but keep things simple. If a pattern doesn't really resonate with you and it feels like it's actually adding overhead, or you're finding yourself kind of hacking it too much, take a step back, try a different pattern, keep it simple. Find what works for you. So with that, I'm going to go through some common design patterns. And I know you're all thinking there's a couple on here that aren't even POROs, but bear with me. I'd like to set a bit of a foundation as we go into that. So we're going to talk about database wrappers, modules, services, API wrappers, virtual domain models, and request and presentation objects. There are far more sort of ways you could categorize these, but it's kind of the perspective and the categories that I've started come up with in the last few years. So we'll start with database wrappers. And what are they? Database wrappers, oftentimes a lot of us write with Rails or other frameworks that are using object, relational mapping and ORM, right? They provide a really nice interface for working with your database tables. Rails in particular has a really wonderful DSL for making querying simpler, defining your relationships, and defining things like constraints, right? Either validations or other things like that. And one of the patterns that I've tried to converge on, and maybe you've seen these in literature that you might have read, but using the ORM is really, really helpful, but it can get unwieldy very quickly, right? You can start to include a lot of other things in your model classes that maybe don't really have to do with the database, but maybe have a lot more to do with the business or domain logic that you're trying to do with that table, but it's not intrinsic to the table. So one of the patterns that I've kind of converged on is really focus on making that class, so whether it's an active record model, really focus on keeping that class specific to what you need to know about the fact that it's a database table, and start to use some of those other patterns to encapsulate other business logic. So I know a lot of active record is probably really familiar to everyone. One other thing I did want to point out, though, about ORMs that is really nice is you can use them for any schema. I realize that might sound so obvious, but it was a real aha moment for me several years ago when I was a less experienced developer, to really see the power of the different ways that I could work with a database without necessarily being, a SQL expert or something like that. So just going to throw up a couple examples of what I'm talking about here. So on this side here, I don't want to stand in front of it, just a classic, model on the public schema, this workout plan, right? Like I said, kind of just focusing on relationships, constraints that I might have, and very simple instance methods that, maybe help out with slightly more complex relationships, right? And kind of keeping it to a narrow scope in that way. And then on your right there, an example of what I mean about just so easily being able to work with other schemas. At Launchpad, we work a lot with Salesforce and integrations with that through Heroku Connect, which instantiates a Salesforce schema for you. But being able to create an active record wrapper around that made it so much easier to sort of reason about the fact that it's just another table in your database. All right, so the next non-PORO is the modules. And modules are really great. It's something I've had a lot of fun exploring with and playing around with a lot more as I start to better understand their purpose. But modules in Ruby are actually really simple. It's just a collection of code, right? You might find a lot of examples where people use modules for namespacing, and that's all it's doing, right? Is you might have a handful of classes that are sort of related, but you kind of keep them in different classes because they're focused on their own thing. But you might want them related another way, so you can use a module to namespace. A couple things to know about modules: they cannot be instantiated. You can't have like an instance of the module that you define. A module is an instance of the module class, but that's neither here nor there. And lastly, as I alluded to, modules can be either used directly, right? You can sort of expose the methods on the module with the self notation, or you can extend other bundles of code, so classes or other modules with prepend, include, or extend, like we heard earlier. So the common ways you probably are seeing them or maybe using them yourself are model concerns. So this is a great first step in kind of keeping your model class a little bit simpler in terms of focusing on the database. Like I mentioned, maybe the first step is use a concern to kind of encapsulate some other things you want to do with the table. We'll find some other patterns later to pull it away a little bit further. In a similar fashion, controller concerns and view helpers are really just modules, right, that get included for the view layer. But the last two here are the ones that I've been trying to play with a little bit more. So much like a model concern, using a module to capture shared logic that you might use across POROs. And lastly, something one of my mentors kind of told me or kind of like shaped a new perspective for me was the idea of using modules to kind of represent a little bit of functional programming in Ruby. Functional programming just being at its simplest form, the fact that you can give it the same input, get the same output every time, right? You're not really managing state or changing state or anything like that. And that perspective really helped me think about using modules sort of with that heuristic. Anytime I want to just do operation or something like that, I start to reach for a module first rather than trying to use object-oriented programming or something like that if I don't really need an instance of it. So those are a couple of heuristics that I've started to use. So examples of the things we've talked about, again, you've probably seen these already, but for the purpose of this talk, you say I've got two tables that both have sort of address fields on them, and I want to dry up my code and just find different ways to share logic between them. I could use a model concern or a concern for those address fields. On the controller side, a controller concern we use a lot at Launchpad for our APIs is for exception handling, not just sending the exception response back, but also capturing it with Sentry. So we kind of consolidated that logic and include it for all our controllers. And lastly, just an example of a helper. I think view helpers are great. They're so simple. You can define all your sort of like messy display presentational work in this helper, and it's just automatically loaded for you. I think they're kind of like understated sometimes, but I'm a huge fan, and they're very simple. But lastly, so the calculation example that I provided earlier, maybe I need to do some work. Maybe my database table persists sort of raw values, but for other purposes, I want to have some calculations. So I might have some methods here where I'm just, I give it an input, I get an output, it's the same every time. In this example, I am using the class self notation. I'm exposing all these methods. And this is an area I've kind of gone back and forth on. You can easily include workout metrics and not have the class self notation there, or not have any selves on here. But one thing I've started to think about, as I echo the idea of sort of like documentation and communication, is it's a lot easier to find something if you get to call the module, right? So I might call in the code workout metrics dot, convert distance, rather than say maybe I've got a really long file, I include workout metrics at the top, but I'm not using convert distance to the end. Like someone may have trouble kind of reasoning about where that's coming from. Certainly there are tools to quickly find definitions, but for the sake of reducing your cognitive load and steps, this is a really handy way to help self-document your code and help out the other developers on your team. All right, well, I made a major faux pas. Been saying this word, this acronym PORO, and I haven't even defined it yet. Very bad for presentations and writing, so let's do that. So what is a PORO? A PORO is just a plain old Ruby object, right? It's a really cute little moniker that's being used to distinguish really any Ruby class from a database wrapper. That's kind of why I wanted to start with the database wrappers, to kind of really pull out that distinction, but it's just any Ruby class, right? So let's talk about POROs. As I said earlier, I've got a few categories of examples here: services, API wrappers, virtual domain models, and requested presentation objects. All right, services. So I know there's been a lot of wonderful articles and perspectives and point of views on what really is a service class. I'm going to give you my perspective. There's a lot of ways to do it, and maybe this is the one that's the hot take, but the reason I decided over time to lean into it is because I wanted to be more specific about the other patterns. Services has become this kind of catch-all phrase for kind of all your POROs, but we can do better. We can create more names for things. So in the apps that I write, services are POROs that encapsulate business logic, but usually for calculations, transactions, or a series of steps for procedural code. I personally have really leaned into that. I know that there are different perspectives out there. The great thing about services, so even though they're procedural code, and maybe you're thinking that's not really leveraging all the great functionalities of object-oriented programming, you can still take advantage of some of those benefits, right? You can expose some methods using some of the convenience helpers like add or reader, or just define public methods. And you can also leverage inheritance. So it's another way to kind of share code amongst your service classes. Perhaps you have a sort of notifications top-level service that can handle processing notifications, but you have slight nuances between processing an email notification and a text notification. Perhaps a sort of inheritance pattern for your services processing notifications might be really helpful in that instance. So the way that I've come to use them, and a lot of my teammates use them, is we expose one public method, usually that run, perform, call. Some people like to also make that one method be the name of the sort of action that's happening, and that's great too. Often you'll see these named as a verb as a noun, so PDF generator, or the verb itself, right? So generate PDF. I've started to converge that way, but all the ways are great. And lastly, the other heuristic or pattern that I converged on is leveraging mostly add or reader for the key attributes of the class. And I've actually recently been changing my perspective on this a little bit after kind of talking to some more teammates. I used to always make the attributes that I use in the initializer, I used to use add or reader because it was just convenient. I didn't want to write the instance variable symbol everywhere, right? But in reality, that's kind of misleading because it's actually making a public method for you. And maybe I don't actually want to expose those variables. So maybe I'm a lazy developer, I love shortcuts and all those things, but documentation is way more important to me. So I've started to go the other way and be more intentional about things like add or reader for the attributes that I actually want to expose. Or I just honestly write the method, which is another way to communicate that. So with that, I've got one example of this sort of like procedural approach. So perhaps I'm working with the Under Armour API with map-my-run, and this is actually for an app that I built a long time ago, but I wanted to tweet my progress while I was running a half marathon, my first half marathon, and really I just wanted to play around with some Ruby and some APIs. So I had this service that, it fetches workouts from the API, and we'll see a little bit in the next section. It persists some of that workout data in my database, and then it goes ahead and tweets out some of that information, right? And you can imagine that there's some more code here, but the idea is there was a series of steps. And one of the examples of perhaps exposing something, kind of leveraging that facet of it being an object or an instance of the object, is that errors instance variable there, right? So let's say something happens with the persisting it in the database, and the code that's calling this, maybe it wants to know about that. Maybe it needs to not do additional code if there's an error. I've exposed that errors method so that that code can work with it. All right, so that nicely brings us to this next category of POROs, which are API wrappers. This is a slightly specific category, but I think it hopefully resonates with many people here. So what do I mean by an API wrapper? I'm referring to a PORO that represents a reusable class to interact with external APIs. This could also include interacting with gems or SDKs that have already done a lot of that legwork for you, but maybe you want to be able to provide some of your own business logic along the way. You can use this pattern. So generally speaking, these are an interface for working with those APIs, and they often do certain work like abstracting away some of the internal details of actually making the request. So whether you're using HTTP party or the net HTTP directly, or maybe you're using SOAP or XML, it doesn't really matter at the end of the day. Once you sort of build your wrapper around it, you can go ahead and make any request to the API that you're working with. The way I've generally approached it is to define methods for the RESTful route. So perhaps my API wrapper has a get method, and maybe all it does is it calls http-party.get, but I can easily sort of switch that out for a different version, right? And then I often include sort of overridable methods or hooks for each endpoint may need a slightly different version of something like the headers, right, or the payload. So I allow those subclasses to pass those in, and then any other boilerplate or reusable code that working with the API might need. So an example of this, as you kind of saw earlier, I've been working with the Under Armour API, and so you can see here that I've got sort of a defined method for get there. Like I said, I happen to be using HTTP party. I also define on the right-hand side there both a required method, the endpoint, right? So that API has several different endpoints for its different resources, which I might want to encapsulate in different subclasses, as well as, like I mentioned, sort of optional hooks that can easily be overwritten, and with some of them with default states. So kind of seeing that in action would be if I want to work with their workouts endpoint, I've got this maybe activity data subclass, and it can go ahead and call that get method really easily, but it can also go ahead and define the specific headers. In this case, we needed to pass some authorization info. If I had, if I was modifying some data and I was hitting a post or a put or a patch, maybe I would want to update the payload as well and pass in some body parameters as well. And I've also sort of updated the after init hook in case there was sort of other data that this subclass needs. This also is a great segue into the next section, because what am I going to do with all those results of the API? That takes us to this fifth pattern, which is, I call it the virtual domain models, and not just me, a lot of people call it that. But really this pattern is going to be probably what a lot of people most traditionally first think of when they hear POROs, is they hear it sort of as the kind of a counterpart to the ORM table. You have a class that kind of represents something that should be modeled in your database, or sorry, modeled in your application, but you don't want to persist. So that's exactly what these are, right? They're not database tables, so usually you might define these for data that might be a bit more transient in nature. You might want to use them almost immediately in a view layer or something like that. And the way that I've kind of seen this a lot and kind of converged on is it looks a lot like how you might write a schema, right? So you might have public methods for the attributes of that model. I've also seen a lot of patterns where folks might also write the sort of the CRUD actions to actually sort of make it feel a little bit more like an ORM table. For instance, we had worked with the Contentful API. Contentful is a CRM, and they use a concept of models to build your pages. And they have a really nice gem, but we wrote another wrapper around it where we ended up sort of defining methods that felt a lot like Active Record because it was familiar to us and easy to use, but in reality, we weren't actually persisting that Contentful data. that ended up being really helpful for us and also helped us learn a lot along the way. So as I've kind of alluded, a really common use case for these are for API results. I've also used this to sort of memorize calculations where there's a lot of interdependencies. I was working on a finance app where we were doing some financial projections, and certain line items needed to refer to each other both ahead and behind. That is, if you have 3 line items that are kind of in order, the second sort of line item that we had to project for this calculation maybe had to use a result from the first line item, and maybe actually also had to use a result from the third line item, which at first sounds a little bit recursive and tricky. But at the end of the day, coming up with a sort of virtual domain model to represent the line item made that so much easier to reason about, to sort of understand, and also test at the end of the day. So we'll keep working with that Under Armour API. This is a really, really simplistic example, but as you can see, the wrapper takes in the results, so the parsed JSON from the API. This wrapper happens to know where in the results to dig, but maybe you want to do that earlier, and that's okay too. But you can see I have the public methods for just the different attributes that I might ultimately want to work with. I can then go pass these into the calculator that we worked with earlier. I could also call the calculator directly in here and make that part of the model. You could start to see how a lot of these patterns actually interact and overlap in different ways. All right. Sorry, I forgot that I include an example of how you might actually use this. So like I said, I might fetch those workouts. That result, as you can see, because it's pluralized, it returns an array of hashes, and I can go map over those and maybe display a list of all the workouts that I fetched from the API. All right, and that brings us to our last sort of category that was defined here, request and presentation objects. So these are another answer to trying to make some of the base components of your apps, your controllers, your view layer, just a little bit simpler, and also to maybe harp on some of the solid principles like single responsibility. So there's a lot of examples of these, and I think this is the area where there are actually a lot of great libraries and tools that developers have come up with as a way to abstract kind of their perspective on it. But at the end of the day, these are just POROs. They support, like I said, the request or response or presentation layers, right? Your view or sending it out to a client that might be rendering the data. And as an opportunity to reduce sort of that complexity in your MVC layers, as well as one of the big proponents that particularly a lot of these libraries advocate for is that they are easier to test. A class with some simple instance methods is a lot easier to test than, say, a whole request from the controller or the view layer, right? There's a lot of data setup involved. When you can kind of break that down with some of these POROs, it's a lot easier to sort of reason about, extend the functionality and test that functionality. So the names here are kind of the common names that you might see for them. So there's a lot of ways to refer to the presentation ones. Some people call them presenters, and they might kind of write them themselves. Some people might call them decorators, and there's a really great gem Draper that provides a nice interface for that. And View Components is also another wonderful library that really advocates for that easier testing approach. I've also included in here serializers. I think that's something that kind of gets overlooked sometimes, but it's just a class that modifies their data so that it can send it to the client that needs it in the format that it needs. And the last one on here, I wasn't actually sure what the name for this was, so I call them transformers. These are kind of the opposite of the serializers. They might either parse your data or transform it to coerce it into the data structure that the receiving code might need. So for example, if we receive a date string from a React client, Ruby doesn't really know what to do with that depending on how it comes in. So you might want a transformer to help coerce it into the date object that Ruby knows and expects. So a few examples of these. I put up here both View Components and the decorator using Draper. So View Components, you define this class, and again, you can provide it some instance methods that you can then go use in your views or your partials. Draper works in a very similar fashion. One nice thing about Draper is that it really resonated with me in the way that it's basically just creating a new object that is the decorated form of the object that you pass it to. And you really then have two objects available to you. So perhaps I've got my database version of my workout object, it's got that raw distance, that raw speed. If I decorate it, I now have another object that sort of has these more string-based versions of those attributes. And you can always, the nice thing that Draper does as well is, it includes an example, but you can sort of like delegate methods so that if you don't want to actually modify something for display purpose, you just want to use the actual attribute the way it is, you can go ahead and do that. And you always get the original raw object exposed as well. So if you want to go that route, you certainly can. And then on the flip side of that, so I sort of put these together, right? One is outbound, one is inbound. So a serializer, we happen to use fast.json with some of our own helpers, but there's a lot of ways to do that. The idea is it's formatting the data, right, so that someone can receive it. This other one here, this transformer, shameless plug, it's our open source internal tool that we wrote called Decanter. We really like it. It's kind of a combination of strong parameters and this idea of kind of coercing values into the way that you define them. So you can restrict the inputs that you will accept. You'll curse them into the way that they need to be. So if they did come in a string and you want to make sure that they're an integer before they actually hit your logic, you can do that. You can also ignore certain attributes that should not be passed through. And all sorts of things. So I encourage you to check it out. I think it's a really, really neat tool. Liked it a lot. We use it in a lot of our projects. One other example of the presentation layer that I wanted to point out that I didn't list was also form builders. So it's another great way to reduce logic in your controllers. If you have some really complex form, usually with associations and children's. I know I always get tripped up trying to remember the exact syntax with Rails ERB for some of those forms. So taking a step back, using Ruby to just write a couple methods to build your associations has been a really helpful way to debug and test, like we mentioned earlier. So that was it. Those are the patterns that I've been working with, some names I've tried to come up with for them. I really want to hear about how you all may be applying these patterns or do them a little bit differently, or what names and vocabulary you have come up for them. So yeah, feel free to come chat with me afterwards, but I appreciate you all being here today. Thank you.